Okay, so we're going to start tossing coins, which is a fairly standard thing to do with probability. We're going to toss a fair coin, right, 5 times. Now, a fair coin means that there's an equal probability of a head or a tail. And remember that a head is mutually exclusive with a tail, right? You can only toss, you get one or the other, right? So probability of head equals probability of tail equals 0.5. All right, so what we're after is the probability of at least one head. Now, that's actually quite difficult because we're doing this thing 5 times, right? So possible outcomes are, head, tail, 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 head, right? That's one possible outcome. You got head, 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 tail, tail, right? There's many different possible outcomes. It's too difficult to count all of these different ideas, all the total number of these things, right? So it's actually easier to use the idea of complementary events. The complement of at least one head is 0 heads. Or all tails. Now, it's actually pretty easy to figure out what the probability of all tails is. Each toss is independent, so we can multiply all the different probabilities together, but we know what that is, right? So prob of 5 tails, 1, 2, 3, 4, 5, that's just going to be equal to 0.5 for the first tail times 0.5 for the second tail times blah, blah, blah. Right, 0.5 to the power of 5. Okay, so you'd have to work that out, what it is, and then the probability of at least one head is then 1 minus the probability of 5 tails. Which is this number here. So 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, so that is equal to 31 on 32. Right, so it's pretty likely that you'll see at least one head if you toss a fair coin 5 times.